Hello friends, today I am going to teach you what is the Carnot cycle and many things about Carnot cycle. So before explaining this Carnot cycle, I want to say you that if you want to learn about these cycle like Carnot, Otto and diesel cycle, etc., that so you have to learn that the what is these four properties of the gas is like pressure, volume, temperature, and entropy. These are four properties during the any cycle like 1 to 2, which is isothermal expansion, 2 to 3, 3 to 4, and 4 to 1. The one property of the among them, pressure, volume, temperature, and entropy, will be remains constant, other will be varying. So during the you can see that the during process 1 to 2, in the isothermal expansion process, here you can say that temperature is constant and entropy which is varying, the pressure which is varying, and volume which is also varying. So you can understand that the one property will be constant and other will be varying. So now let's get started with the Carnot cycle. The Carnot cycle, who invented the Carnot cycle? The Carnot cycle was devised by the Nicholas Leonardo Sadi Carnot to analyze the problem of a efficiency of a heat engine. So basically the Carnot cycle consists of two processes, that two isothermal processes and two reversible adiabatic or isentropic processes. So what is the isothermal process? Is a process. What is isothermal process? The isothermal process is a process in which temperature of the gas remains constant during the entire process, is known as isothermal process. And what is the reversible adiabatic or isentropic process? A process in which a reversible adiabatic or isentropic process, a process in which the entropy of the gases remains constant, is called isentropic or reversible adiabatic process. Now, first one, the 1 to 2 process, which is isothermal expansion process. In this process, the it is isothermal, so the temperature of the gas remains constant. So here it is constant during process 1 to 2. T1 is equal to T2, and it is expansion process. So the gas, so the expansion process. So the pressure of the gases will decrease. So pressure P1, here the pressure from starting the pressure was P1, and it is decreased during the isothermal expansion process, and now it is pressure P2, so it is decreased. During this process temperature is constant and entropy will increases. Now process 2 to 3, 2 to process, which is isentropic expansion process. So it is isentropic process, though entropy will be constant, and expansion process, the pressure will be decreases and volume will increases. So pressure P2, which will be after expansion process, isentropic expansion process, 2 to 3 decreases, and it will become P3 at this point. So it is decreased and volume will increase. So at this point volume was V2, and it is increased. So at this point point 3 it is V3, and process 2 to 3, in TS diagram the 2 to 3 entropy will be constant, so it is a constant, and temperature which is decreased from T2 is equal to T1, which is T2 from T2 to T3, it is decreased. Now process 3 to 4, which is isothermal compression process. So first thing is that the what is the isothermal compression process? In which the compression is a process in which the pressure of the gases will increase and the volume will decrease. So we can see that during process 3 to 4 the volume was V at point 3, volume was V3, and at point 1 volume is V4. So volume is decreased during this 3 to 4 process, and the pressure which is 0.3 what P3, and at 0.4 which is increased at P4. So during this process, now see the TS diagram. During this process 3 to 4 the entropy of the gases will decreases and the temperature remains constant because it is an isothermal process. Now process 4 to 1, which is isentropic compression process. As I told you that isentropic process is a process in which pressure of the gases will increase and volume will be decreased. So during process 4 to 1, pressure which is P4, it is increased to the P1 which was at the starting, and the volume which is at this point point 4 V4, it is decreased to volume V1 at the same as the starting point. Now see the TS diagram. In the TS diagram during process 4 to 1, which is isentropic compression process, so it is kind of isentropic process, the entropy of the gas remains constant, which is remains. Here we can see that it is remains, and the compression process, and so the temperature of the gases will increases. So the temperature T4 it is increased to the temperature T1.